Let's continue looking at using integration to find area. So you remember the formula, the integral from a to b of f of x dx. That is the area. So as we pointed out in earlier videos, this area is between x equal a, x equal b, the x-axis, and the curve of f of x. So that is this shaded area here. All right. Now let's look at another example. What I want you to do is find the area bounded by x equal 1, x equal 15, the x-axis, and y equal what would they say now? Y equal 2x plus 3. Okay, now remember, we also call this f of x. So let's stick with f of x for now. F of x equals 2x plus 3. Now, this is a linear function. So let's use two methods to see if they will yield the same answer. Let's draw our x-axis and y-axis first. So we have our x-axis, we have our y-axis, we have the point where x equals 1, let's say 1 is here, and say 15 is here. 2x plus 3 at 1. F of x would be what? 2 times 1 plus 3, which is 5. So f of x would be 5. So when x equal 1, f of x is equal to 5. Let me just adjust this here. So what happened at x equal 1? F of x, well, is f of 1. So f of 1 is equal to 2 by 1 plus 3, which is 5. And what happens at x equals 15? F of 15 would be 2 times 15 plus 3, which is 33. So let us say our 5 is here and our 33 is way up here. All right? Let's get an idea what this curve or this line will look like. It starts here and ends up somewhere there. So therefore, the area that you're calculating is this. That's the area. Now, let's do it the old time conventional way. Suppose what we have here is a trapezium. Suppose we cut it into a rectangle and a triangle. The area of the rectangle, the area here, call it area 1, is equal to the width. 15 minus 1 is 14. 14 times the height, 5, which is what? 5 4 is 20. You know, 0 carry 2, 5 1 5 6 7. 70 units square. 70 square unit. And the area, call it 2, area 2, the area of the rectangle, the triangle, is half times the base. From 1 to 15 is 14, so it's half of 14 times the height. How high is it? It starts at 5 and ends at 33. So 33 minus 5 is what? 28? Alright, so that's half that by 14 by 28. All right. Now, that area, half of 14 is 7. So 28 by 7 is what? 7, 8, 56. Bring down the 6, carry 5. 7 2 is 14, 15, 16, 17, 18, 19. 196. So we have 196. So the area, the total area, call it AT, area total, is 196 plus 70, which is 6 and 0, 6. 7 and 9 is 16. Bring down the 6, carry 1. 1 and 1, 2. 266 square units. Okay. So we have 266 square units. Now, let's use integration and see what would happen. Based on what we have here, we're integrating from 1 to 15. So we find the integral from 1 to 15 of, what's the function again? 2x plus 3 of 2x plus 3 dx. All right? So here, what we have, let us do the integration from basics again. It's 2x to the 1 plus 3x to the 0 if you include the powers of x. So what we're finding is the integral of all of this dx. And remember, you can also consider integrating each of these separately. So while you can do both of them at the same time, you could very well also have it in the form 1 to 15 of 2x to the 1 dx plus integral from 1 to 15 of 3x to the 0 dx. All right? But in any case, you're going to have, it's more convenient to do both of them at the same time. You're going to have this being equal to 2x to the 1 plus 1, which is 2, the new power divided by 2, which is the new power, plus 3x to the 0 plus 1, which is 1, divided by 0 plus 1, which is 1. Or you wouldn't really need to write this. So, here, let us imagine that you put a plus c there. All right, let's put plus c and see what's going to happen later on. So that's the integral we have. So here now, you have x squared plus 3x plus c. Oh, my, I overlooked something here. You should have these in square brackets and put the boundaries. You're going from 1 to 15, all right? So here now, this is x squared plus 3x plus c from 1 to 15, all right? So now, you have 15 squared plus 3 times 15 plus c minus, substitute for 1 now, 1 squared plus 3 times 1 plus c. Now, 15 squared is 225 plus 15 3 is 45 plus c minus 1 squared. Now, when you open this bracket, the signs inside will change. 1 minus 3 1's 3 minus c. See that? Now, numbers together, 225 plus 45 minus 1 minus 3, then plus c minus c. Notice the c's subtract each other. So So when you do definite integration, which is integration to find areas, which means you define the boundaries of the integrals. That's definite integration. You do not need to put in a constant of integration because it will subtract itself anyway. So let's see what happens here. 225 plus 45 is what? 25, 35, 45, 55, 65, 270. Right? So 5 and 5, 10, bring down 0, carry 1, 4, 5, 6, and 1, 7, 270. Minus 1 minus 3 is minus 4. So you get 266 square units. Was it the same thing that happened? Let's see what happened before. 266 square units. So we get back our 266 square units when we find the area using integration. So here, remember now, note, this is what they call definite integration. What we were doing before, or when you don't define boundaries, then that's indefinite integration. This now, you define the boundaries to the left and the right. The boundaries would be these lines here, representing x equal 1 and x equal 15. So that's definite integration. Now, you do not need to put the constant of integration when you do definite integration because the constant will subtract itself. Alright? So, like I said before, we carried out this calculation using conventional trigonometric measurement techniques. We get 266 square units. Then we use integration and we get 266 square units. So there we have our answer.